Hello students, welcome to BakoMaths. And to this lesson, we'll be looking at conjugation and rationalization of sets. And so if you have not subscribed to this channel, kindly subscribe and hit on the notification bell so that when a new video is being uploaded, you'll be the very first person to be notified. Now, let's get started. In this video, we are going to solve two examples. And example 1 says that we should express 3 root 2 plus 4 root 3 divided by 6 root 3 plus 2 root 2 in the form p plus q root r, where p, q, and r are rational numbers. So we have our solution as. Now our question was 3 root 2 plus 4 root 3 divided by 6 root 3 plus 2 root 2. So what we are going to do here is to find the conjugate of the denominator and rationalize. Now if you have not watched my video on how to find the conjugate of set, kindly click on the link above and watch that before you come to this side. And then also, if you have not watched the video on how to rationalize sets, you can also click on the link above and understand before you come to this example. In other words, if you understand, we proceed with this solution. So now the whole idea is to find the conjugate of the denominator, that is 6 plus root 3 plus 2 root 2, and after we rationalize. So finding the conjugate simply means that we are going to change the sign in between 6 root 3 and 2 root 2 to its opposite sign. So the opposite sign of plus here is minus. Now when we have that, we multiply by both the numerator and denominator. So in simple terms, it means that we multiply the numerator and denominator by the conjugate of the denominator, that is 6 root 3 minus 2 root 2. So this is actually the conjugate, and then as we continue to multiply it by the denominator, it becomes rationalization. So as we change the sign of the denominator to its opposite sign, it becomes conjugate. As we multiply by both numerator and denominator, it becomes the rationalization. So we've been able to rationalize and conjugate. Now we continue with our solution. So here we can see that we can multiply the numerator. So taking the first term to multiply everything at the right hand side, we have 3 root 2 multiplying the whole of 6 root 3 of the numerator minus 2 root 2 of the numerator. Now also take 4 root 3, also multiplies everything here. So that is plus 4 root 3 multiplied by 6 root 3 minus 2 root 2. So we complete the same process for the denominator, all divided by. Now we take 6 root 3, which will multiply 6 root 3 of the right hand side minus 2 root 2. We also consider plus 2 root 2 of the left hand side here. It also multiplies everything at the right hand side, that is 6 root of 3 minus 2 root 2. So now we have it at this way. We continue by simplifying both the numerator and denominator. So considering the numerator, 3 by 6 gives us 18. So you have 18. And then root 2 times root 3 gives us root of 6. Now 3 times 2 gives us 6, but there is minus in between them, so that becomes minus 6. And then root 2 times root 2 gives us root of 4. Plus 4 times 6 gives us 24, and we can see root 3 times root 3 gives us root of 9. Now 4 times minus 2 gives us minus of 8. Root 3 times root 2 gives us root of 6. So we have this as such. Now we continue with that of the denominator, and we can see that 6 times 6 gives us 36. Root 3 times root 3 gives us root of 9. And then 6 times minus 2 gives us minus of 12. Root 3 times root 2 gives us root of 6. We continue, and we can see 2 times 6 gives us 12. So root 2 times root 3 gives us root of 6. Now minus 2 times 2 gives us 4, and then root 2 times root 2 gives us root of 4. So we simplify it as such. Now we continue, and we can see that there are like sets here, and then we can also simplify some of the sets in the numerator. So in the numerator we have 8 root 6, and then minus 6. We can see root of 4 is the same thing as 2, and then plus 24. We can also see that the root of 9 gives us 3. So you have minus 8 root 6 divided by the denominator. So 36 maintained, and we can see that root of 9 gives us 3. And at this point we can see minus 12 root 6, and then you have plus 12 root 6, so they will cancel out, giving us 0. So we continue with 4, and then we know root of 4 gives us 2. So we have this as such. We continue at this side. So by simplifying the numerator again, we can see we have 18 root 6, and then 6 times 2 gives us 12, so that gives us minus 12, and then plus 24 times 3 gives us 72, and then we maintain that of 8 root of 6. We divide everything by 36 times 3 gives us 108, and then minus of 4 times 2 gives us 8. Now at this point we can see like sets here, and then rational numbers. So here we group the rational numbers first, so that gives us minus 12. So we have minus 12 plus 72, and then the irrational numbers, that is plus of 18 root 6, and then minus 8 root 6. So we divide by 108 minus 8 gives us 100. So it's now equal to minus 12 plus 72 gives us 60, plus, now because 18 root 6 and minus 8 root 6 are like sets, we can see root of 6 and root of 6 here, they are like sets. We can proceed by subtracting. So 18 minus 8 gives us 10. Now we repeat the root 6, all divided by 100. At this point we can divide the numerator by the denominator according to the terms. So here we have 60 divided by 100, and then we have plus of 10 divided by 100 root of 6. And we can see that when 60 divides 100, it gives us a final answer of 3 out of 5, and then when 10 divides 100, it gives us 1 out of 10. Then repeat our root 6. So at this point we have been able to find the solution to this question. Now we compare with the question which says that we should leave our answer in the form p plus q root r. So just like we just did, we have our solution as such, so which implies that p, so we're leaving our answer in p plus q root r. By comparing, we can see that our p here is equal to 3 on 5. We can also see that q is equal to 1 on 10, and then r is the actual value, not the root, is 6. So this becomes the solution to our first question. Now we proceed to the next question, that is question number 2. So example 2 says that we should simplify 8 minus 3 root 6 divided by 2 root 3 plus 3 root 2 in the form p root 2 plus q root 3 and evaluate p plus q. So we have our solution, and the question was giving us 8 minus 3 root 6 divided by 2 root 3 plus 3 root 2. So just like we said, we find the conjugate and we rationalize. Now at this point, if you have not subscribed to BakoMaths, kindly spend a moment and subscribe, and then you comment as you like as well. Or you can also pause the video and try your hands on this question. If you're not getting it later, you resume and then check out the solution. So we continue by saying that we find the conjugate of the denominator and then we rationalize. So find the conjugate means that we change the sign in between the terms in the denominator. So we find the conjugate as 2. That gives us 2. So multiply by 2 minus, so you should get 2 root of 3 minus 3 root of 2. So this is the conjugate, and then we divide it by the same thing. So in this process, we are rationalizing. So we found the conjugate and rationalize. This is what we have. So we continue by multiplying the terms one after the other. So when we consider the numerator, we have 8, which multiplies everything at the right hand side. That gives us 2 root 3 minus 3 root 2. And then we continue with minus 3 root 6, which also multiplies everything as 2 root 3 minus 3 root 2. Now we divide, and at this point we have, that is, we consider 2 root 3, which multiplies everything at the right hand side. So we have 2 root 3 minus 3 root 2. And then also consider plus of 2, that is plus of 3 root 2 multiplied by 2 root 3 minus 3 root 2. Now we continue by expanding, and that gives us 8 by 2 gives us 16. So we maintain our root 3. So you have 16 root 3. 8 by minus 3 gives us minus 24. So that gives us minus 24 root 2. We continue with minus 3 times 2 gives us minus 6. And root 6 times root 3 gives us root of 18 minus. So minus and minus meet, we have positive. So that gives us plus. So that gives us plus of 8. So that gives us plus of, so 3 times 3 gives us 9. And then root 6 times root 2 gives us root of 12. All divided by, so when we simplify the denominator, we have 2 times 2, that gives us 4. So root 3 times root 3, that gives us root of 9. Minus 2 times negative 3 gives us negative of 6. And then root 3 times root 2 gives us root of 6. Now we continue with the next, that gives us plus of root 3 times 3 times 2 gives us 6. Good. And then root 2 times root 3 gives us root of 6. Minus, so 3 times 3 gives us 9. And then root 2 times root 2 gives us root of 4. Now we simplify. Now we can see that in questions like this, whenever we simplify and simplify it properly, we can see that the denominator has terms of which they can cancel out and go to 0. A clear example is what we have here: minus root 6 plus 6 root 6. This is a clear instance where they will go to 0. So if you simplify and then you don't end up getting the 0, these terms cancel now to be 0 here, that means there is something wrong with your simplification. So you have to go back and check it out. So we look at example 1 like that, a similar instance happened. Now we continue by looking at the numerator, and at the numerator we have 16 root 3 minus 24 root 2 minus 6 root 18 plus 9 root 12. Now we look at square root of 3 and square root of 2. They are in their reduced or basic form, so we don't simplify it again. But for square root of 18 and square root of 12, they are not in their reduced or basic form, so we have to reduce or simplify it. So now we have 16 root 3 minus 24 root 2. So there comes that of 6 root 18. So in simplifying square root of 18, we consider the factors of 18, of which they are 1, 2, 3, 6, 9, and 18 itself. So among the factors of 18, we identify the perfect squares. The only perfect square we have here is 9. So we take the perfect square and multiply by any of the factors that gives us 18. And that number is what? Is 2. So it means that when we take 18 now, it's basically the same thing as 2 times 9. So when we take square root of 18, it's basically the same thing as square root of 2 times square root of 9, of which we can also simplify this square root of 18 as square root of 2 times square root of 9. So here we have square root of 18 to be written as square root of 2 is 2, that is square root of 2 itself, and square root of 9 is 3. So at the end we have 3 root 2 for square root of 18. So it means we can reduce or simplify square root of 18 as 3 root 2 by considering the illustration we did. So we continue. So in place of square root of 18, we write 3 root 2. So at this point, we have multiplied by 3 root 2 and then plus 9. So you also have to simplify square root of 12. And in simplifying square root of 12, we consider the factors of 12. The factors of 12 here are 1, 2, 3. We have 4, 6, and then that of 12. So among the factors of 12, we identify the perfect squares. The only perfect square we have here is 4. Now, if there are 2 or more perfect squares, you identify the largest perfect square number and you take that one. So since the only perfect square number we have here is 4, we take it, and we take any number among the factors of 12, then we multiply by 4, we get 12. So that is 3. So it means that for 12 is basically the same thing as 12 is basically the same thing as 3 times 4. So when we take square root of 12, then we can also write this as 3 times 4. So square root of 12 can be simplified as square root of 3 times square root of 4. So the same square root of 12 can also be simplified as square root of 3 times 2. So therefore square root of 12 can be written as 2 square root of 3. So in place of square root of 12 here, we write 2 root 3. So we continue with our solution as such, and then at this point we are going to have multiplied by 2 root 3. Now we divide by, so we have 4. Now square root of 9 is the same thing as 3, and then here is going to cancel out, so we have 0. So minus 9, and we know square root of 4 to be 2, so we have it as such. Now solution continues, and at this point we have 16 root 3 maintained, and then minus 24 root 2 maintained, and at this point 6 times 3 gives us 18. So we have 18 root 2, and then 9 times 2 gives us 18. So we have 18 root of 3, all divided by 4 times 3 gives us 12, and then 9 times 2 gives us 18. We continue by grouping like sets and simplify. So here when we group like sets, we have 16 root 3, and then we have plus of 18 root 3, then we have minus 24 root 2, and then that of minus 18 root 2, all divided by, so 12 minus 18 gives us minus 6. At this point 16 plus 18 gives us 34. So you have 34 root 3, and then minus 24 minus 18 gives us minus of 42 root 2, all divided by minus 6, of which we can also simplify. And here we divide both sides. We divide the numerator by the denominator. That is 34 root 3 divided by minus 6. And then you have minus 42 divided by minus 6 root 2. Now we continue, and here we can see that 34 divided by minus 6 gives us minus 17 on 3, and then we attach that of root 3. Minus 42 minus 6 gives us plus of 7, and then we attach that of root 2. So just like the question demanded that we should leave our answer in the form p root 3 plus q root 2, we have it as such. So by comparing, we can see that our p value here is equal to minus 17 on 3, and our q value is equal to 7. Now that we have the values of p and q, it says that we should evaluate. The question said we should evaluate p plus q. So here it means that our p plus q now is equal to minus 17 on 3, and then we have plus 7. So it implies minus 17 on 3 plus 7 gives us 4 on 3. So therefore our p plus q value here is equal to 4 on 3. So this becomes the solution to example 2, and we end today's video here. And so thanks for watching. Kindly like, comment, subscribe, and share. Remember that this is BakoMaths. We are thinking beyond infinity. See you in our next video. It's bye bye for now.